Well, hi there. I hope everyone had a great evening and I hope you had a good class yesterday. So we are going to get started with our lesson today, and it is lesson 712. What if I can't tell? So what does that mean? Let's take a look and see. So your learning targets for today are the same as yesterday. I will write the expression represented on the mat, so we're still going to be doing that. And then I can use legal moves to simplify the expressions on the mat. So we're going to continue to use our legal moves with intention, and we're going to actually learn a new one today. So remember from last class, we were trying to decide which mat was greater. So we used our zeros and our balanced sets to get it down as close as we possibly could, hoping that one side would be 0. And then we stated which mat was greater. So let's start with a nice warm-up and review that process from yesterday. What I would like you to do right now is to pause the video, and in your classwork slides, I would like you to do this entire problem, writing down what the original expression is for A and B, defining what your moves would be, your zeros and your balanced sets, showing all of your moves, and then writing the simplified expression after your moves are done for both mat A and mat B, and then making a statement, which mat is greater. When you are all done, unpause the video and see how your work compared to mine. Okay, so welcome back. So hopefully for mat A and mat B, you had the original expression written the same way I did, and then you used 0 pairs and balanced sets to eliminate as much as possible. You got down to mat A having 4 unit tiles and mat B being at 0. So that makes mat A greater. So hopefully you have no questions on this. If you do, pause this video, ask some questions of your teammates or Miss Paul, and then come back when you are ready. So again, like I gave you a little teaser at the beginning, you've now learned 2 of those legal moves. We have actually 3. So let's put some definition around them. You know the 0 pairs well. It's also called combining like terms. This should be done first, absolutely done first. When you're simplifying equations and expressions, all of these things, you want to get rid of your 0 pairs. It's the easiest way to eliminate tiles. So let's talk about the next 2. We are going to start our discussion by actually doing. So I'm going to pause the video. I want you to pause your video. I want you to draw the expressions on mat A and mat B. Please remember that this is a distributive property. So that means you're going to have 2x plus 6 minus 4. That's what you're going to be drawing on mat A. I will meet you when you are ready. Okay, so hopefully yours looks like mine. You have mat A with 2 positive x tiles, 6 positive unit tiles, and 4 negative unit tiles. Mat B has 3 positive x tiles, 1 negative unit, 1 negative x, and 4 positive x. I want you to get to the point where you have used all of your 0 pairs and your balanced sets, and then come back. So hopefully when you get to the end of all of this, you have nothing left on mat A, and on mat B, you have 1 positive unit tile. So which is greater? That would be mat B. So what we want you to understand at this point is once you do your 0 pairs, so you get rid of these and you get rid of these and these, you can see that you still have these x tiles up here, and you can't have those. So that's the point of removing the balanced sets. When you have this dotted line like we have straight down the center here, and you have things that are the same on each side, you have these 2 and you have these 2. If you remove 2 of the same things on a balanced mat like this, you've not changed the actual amount of the equations on each side. That's why balanced sets works. You cannot take a negative and a positive off of opposite sides because they're not the same. They don't weigh the same. So again, this is reinforcing the idea of balanced sets. If you don't get that, please go back, rewind, and take another look at this particular slide. Otherwise, I will meet you on the next slide. Okay, let's try it one more time. Pause the video, do all of the work, and come back and check your work with mine. Okay, did you get that the mats were equal? After you remove everything, you have 0, 0 on each side. So these are hard, right? Because this looks like a chicken walked over top of our paper with pink paint and green paint. So it's hard to keep track of everything. So let's do a little bit of a challenge. Try to write the original expression for each side of our mat. Then try to simplify and see what you end up with. So when you get to the end of this, you end up with 3 X tiles on mat A and 6 unit tiles on mat B. It's impossible at this point to determine which one is greater because we don't have just numbers, we still have the variable. So the next part of our lesson is going to be kind of unpacking what that means. What does the X variable mean in a situation like this? I think a lot of you are already thinking in a solving for X term. Let's see if you're right. So to help you with this process, I have 3 questions. Our mat A total, 3X, is up on the top of this slide, and then mat B total being 6 is up there also. The first thing I want you to think about is, if X was 0, what does that mean? Well, remember back in Unit 4, we understood that we have 3, and then whenever there's an X, we're going to have parentheses, and we're going to put whatever the value is of X, so that would be a 0. This is going to be 6. So what does that end up transferring to? Well, anything times 0 is 0 and 6, which means at this point, mat B would be larger. Let's take a look about what would happen if X was 2. So we're going to have 3, and then wherever there's a variable, we're going to have parentheses and put the number 2. 3 times 2 is obviously 6, and we're taking a look at the value of 6, so that means at this point, they're equal. What about if 3 was the value of X? Well, 3 times 3 is equal to 9. That would mean at this point, mat A was bigger. So it looks like we have a problem because depending on what the value for X is, we get completely different answers. And this is math. We need an actual answer. So what do we do about that? We have a new move. It's called adding balanced sets. So you understand what taking away balanced sets are. Adding is the exact opposite. Everything in math has an exact opposite. So after removing your 0 pairs and your balance sets, you may still not be able to decide which side is greater, like in our last example. Enter the adding balanced sets. When you do this, it allows you to get your X variables to one side, your unit tiles to the other. How do you do this? You do this by adding tiles to make 0 on one side. It's confusing, so let's try. So this tile can kind of really explain what's going on. You can see on mat A, we have X. And then we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 negative tiles. So on mat A, we have X minus 6. And on mat B, we have 0. Well, that's not helpful for us, isn't it? So X can be any value, but what we want to do is we want to know what value is X. So what do you need to add to side A so that the only thing you have left is X? Well, if you wanted to 0 these tiles out, what would you need? You would need to have 6 positive unit tiles. So if we added that to our mat, 6 positive, 1, 2, 3, 4, 5, and 6. If we added those 6 positive unit tiles, we've changed the actual value of the original expression, which is not acceptable. So the only option you have is to add those same 6 positive unit tiles to the B side, and by doing that, you've actually added just 0, right? We have added plus 6 on this side and plus 6. Well, plus 6 and plus 6 on the same side, it equals out, right? But what it allows us to do, it allows us to do this so that we can actually have a 0 pair times 6. So what's left is X and then 6. So X is equal to a positive value of 6. So this slide is the slide that puts it all together. Let's start by writing down what we have on mat A. So mat A has 4 unit tiles. Mat B has an X plus 1, 2, 3, 4, 5, 6, 7, 8 minus 2. The first thing that we want to do are the 0 pairs. We only have 2 sets of 0 pairs on mat B, right there. Okay, now we want to do our removing of balanced sets. Well, we have 4 on mat A, then we have 4 on mat B, and you can see after this move, I'm going to do this in green. We have 0, we still have that X tile, and we also have plus 2. Well, X wants to be alone. We can't have this right here. So what we're going to do is we are going to add 2 negative unit tiles. We're going to add the opposite in here. We're going to 0 them out on this side. And that's going to leave us with -2 and X. So X is equal to -2. So the legal moves are adding and deleting 0 pairs, adding and removing balanced sets from each side. All right, take that information that we just learned about today and open up your R&P. Try problem 11. And if you have any questions, please make sure you go back and review the information or talk to Miss Paul. And I will meet you again tomorrow with another fun lesson. Have a great day.